Hey everyone, today we're going to talk about coordinate planes and we're going to look at solving one and two-step equations, but mostly we're really focusing on the distance between 2 points when we're using the absolute value. So you have a couple pieces of your template today, so just double check my notebook and make sure that you're setting up your work the way that it should be. Also, make sure that the template is printed out because you are going to want to graph these values as we go. Okay? What we're going to look at first of all is called the coordinate plane, and the coordinate plane is where we graph information called a coordinate point. So we're going to start by filling in some blanks. This is the coordinate point, and it's x comma y. So there's always an x value and a y value. The first number is called the x coordinate, and the second number is called the y coordinate. So, of course, the x-coordinate is going to have to go with the x-axis, or the horizontal number line in our graph, while the y-coordinate follows the y-axis, or the vertical number line in our graph. The very middle, where the x-axis and the y-axis intersect, this is called the origin. And divided by the x-axis and the y-axis, there are 4 quadrants that we're going to look at in terms of graphing. The first is really where the x values go in a positive direction, right? We're going 1, 2, 3, 4, 5. And the y values go in a positive direction. So whenever you plot a point in quadrant 1, it's going to be a positive number and a positive number. Quadrant 2 is over to the left, so we're kind of going in a counterclockwise fashion. And quadrant 2 has x values that are negative, but y values that are positive. Quadrant 3 is just below that, and quadrant 3 has both x and y values that are negative. And then lastly, we have quadrant 4, and you can see that the x values are going to be positive, but the y values are going to be negative. So basically, by looking at our quadrants, we can figure out where points will be located. For example, if I wanted to plot the point 2, sorry about that, 2, 5, first I need to go 2 spaces from my origin along the x-axis. 1, 2. Now I need to go 5 spaces up along the y-axis. 1, 2, 3, 4, 5. And I would be able to plot my point right on that intersection of the line. So that point specifically would be coordinate point 2, 5. I went 2 spaces to the right, 5 spaces up. You're always going to go to the left or the right first, and then up or down second. And you go to the right when it's positive, the left when it's negative, up when it's positive, and down when it's negative. So there's a lot of ways for us to be able to plot some coordinate points. Before we move on, I just want to remind you that the absolute value is the distance a number is from 0. And remember, when we're talking about distance from 0, these are always positive values because distance always has to be positive. So what we're going to do is we're going to start looking at some coordinate points to see if we can find the distance between 2 points. So the first one we're going to do is we're going to look at the distance between the square, which is right up here, and the letter J, which is right here. And when I look around my coordinate axis, I can find the distance easily in one of 2 ways. Because these points are on the same vertical line, I can just count down 1, 2, 3, 4, 5, 6, 7 spaces, and I know that the distance between the square and the j is equal to 7. The other thing I could take a look at is what the coordinate points are. So when I'm looking at the coordinate point for j, I'm looking at something that's 1, 2, 3, 4 spaces over, and then 1, 2 spaces up. So I have a coordinate point of 4, 2. Let's make that just a little neater. Here we go. And when I look at the square, I'm still 4 spaces over, but I'm 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces up. So my coordinate point is 4, 9. As you can see, the x values are the same because they're on the same value for the horizontal distance from 0, but the y values are different. The y value for my square is 9. The y value for my j is 2. 9 minus 2 equals 7. So again, I am confirming that the distance between the square and the j is equal to 7. Let's do another one. I have a cross and a circle, and I want to find the distance between the two objects, so I'm going to count. 1, 2, 3, 4, 5. And I'm going to stop here because the distance that the cross goes to 0 is 5. And then I'm going to start at the circle, and I'm going to say 1, 2, 3, 4, 5, 6. Well, the distance the circle goes to 0 is 6. This is where, in fact, my absolute value comes into play, because if I was going to count straight across that number line, it's okay because distance is always positive. So if from the cross to the 0 is 5, and from the 0 to the circle is 6, then the distance from the cross to the circle is equal to 11 units. Again, I could look at coordinate points and think about how far the cross and the circle are from the origin. So the coordinate point for my cross would be negative 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5, negative 5. So my coordinate point is negative 5, and then for my circle, it would be 1, 2, 3, 4, 5, 6, and negative 5, because we know it's at the same height as the cross. Okay? Let's look at the distance between the music note and the diamond. These are obviously very close together. There is only a distance of 1 unit between the two. And then the distance between the lightning bolt and the bee, we can go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, note that I am counting spaces and not the lines. I'm counting the space between two lines. So each little lump that I'm doing, each little swirl that I'm counting is 1 unit. I'm not counting every single line because in that case I would end up counting the first line and the last line, and I would come out with an incorrect value. So your proof is just to go through and graph a few coordinate points and think about how the distance between those points could be calculated if you know that they're on either the same x value or the same y value.